So I just want to give you a hint on a particular question. There's a question that asks you to form an n-sided polygon inscribed inside a circle, and the suggestion is that as you keep raising the number of sides of the polygon, the area will get closer to the area of the circle. So I just want to show you the how you would calculate the area of the polygon. So what I've done here is the question does not involve a five-sided polygon, which is why I'm going to use five, so I don't give away the answer. I just want to show you the technique. So what I've done here is basically divided this circle into fifths. So let me just draw here what the polygon is. I know that it's not quite regular, but so the polygon is the area inside this straight-sided figure. So here's the thing. This is what's called a five-gon or a pentagon. In general, we have names for things like, we have pentagon, hexagon, heptagon, octagon, etc. For numbers of sides that have well-known Greek or Latin names. But if let's say I wanted to draw a 200-sided figure, we'd call it a 200-gon. That would be the name for it. So this is a five-gon. So the thing you have to recognize here is that what we want to do the area of this five-gon is the area of five separate triangles. So to describe the area of the triangle, of each triangle in terms of how many sides there are to the polygon, observe the following. First of all, I'll just draw it up here. Each of these angles is going to be a full circle, which is 2 pi divided by 5. Okay, so if I divide, I'm going to use this triangle now. If I divide this triangle in half, then what I get here is I get an angle, which I'm just going to put an arrow there, that's going to be 2 pi over 5 times 1/2, or pi over 5. So we can see that this angle here, no matter if I've done 5 sides, that angle is going to be pi over 5. If I had done, say, 17 sides, it would be pi over 17. Now, observe that this is a right angle. So now we can employ everything we know about right triangle trigonometry. We can say that first of all, this length here, since we're talking about a circle of radius 1, that means that this blue length here is just a radius, so it's 1 because it extends from the center of the circle all the way to the outside of the circle. Now, sorry, I keep coloring over. I'm just trying to color code this so I can describe what I'm talking about. This purple side is going to have a length of the sine of this angle. So the purple side is going to have a length of the sine of pi over 10, and the red side will have a length of cosine of pi over 10. I would go over that in detail, but we've already done trigonometry. You've done it in pre-calc, you've done it in algebra. We did it at the beginning of the semester, so just go and review your notes to see why with a triangle whose hypotenuse is 1, the red side is going to have a length of cosine pi over 10, and the purple side will be sine of pi over 10. Okay, so what that means is that I know if I go back to this full triangle here, the full triangle is really going to be two of these triangles. Whereas that pink triangle is going to have an area of 1/2 times those two legs. So it's going to be 1/2 sine of pi over 10 cosine of pi over 10. So that means that the yellow triangle, which now includes the pink triangle, that's why some of it is shaded like that, is going to have an area of twice that. So that's going to be an area of sine pi over 10 cosine pi over 10. So we have 5 of the yellow triangles, so what you're going to do is you're going to multiply 5 times sine pi over 10 cosine pi over 10, and that'll give you the area of the polygon. So they ask you to do a calculation like this with numbers that are not 5. That's why I demonstrated it with 5. All right, so hopefully that hint is helpful to you on the problem.